Some polynomial functions can be graphed using transformations. Our basic functions will be power functions, functions y equal x to the n. We'll apply the techniques we discussed in lesson 4. Let's look at an example. Function f of x is negative 2 times x plus 1 to the power 4 minus 1. So let's list the transformations of the basic function, which in this case is the function x to the 4th. This is the basic function. So let's list transformations of that graph that result in some geometrical transformations. So starting with the basic function, then we are looking for the shift left and right. And we have 1 here. So we'll add 1 to the x and raise it to the power 4. So that means we have to shift left by 1. The next transformations that we look for are horizontal compresses and stretches. There are none here. So next transformation is the vertical stretch or compression, and that is multiplying the given function by 2. So this is the vertical stretch. The next transformation to the graph on the way to the formula for the function f of x would be to add minus sign in front of the whole formula, and adding minus sign to the function means we need to reflect the graph about the x-axis. And finally, we have to subtract 1 to obtain the formula for the function. So we have to subtract 1 from the previous one, and that means we need to shift the graph down by 1. So let's start graphing a basic function. The basic function is x to the 4th, so again we have 0.11, 0.00, negative 1 and 1. 2 and 16 will not fit on the graph, so we'll draw that basic function. This is y equal x to the 4th. This is the first graph. Next, we'll shift that graph to the left by 1. 1 unit is 1 square, so I will move everything by 1 to the left. So the point negative 1, 1 moves to the negative 2, 1.00 to negative 10, 0.11 to the 0, 1. And here is the graph of the second function x plus 1 to the 4th. Then I will graph the third function, which is the vertical stretch. The stretch is 2 times, so it means y coordinate of each point on the graph is multiplied by 2. 0, 0 stay, negative 1, 0 stay where it was. 0.01 will be now 0.02. Point negative 2, 1 will be point negative 2 and 2. And the graph will be stretched vertically by a factor of 2. So this is my third graph. Then I need the graph of negative 2 times x plus 1 to the 4th, which means I need to reflect the graph 3 about the x-axis. So point negative 1, 0 stays where it was. Point 0,2 reflects to become point 0, negative 2, and point negative 2 becomes the point negative 2, negative 2, and we draw the reflected graph. And this is the graph of the function negative 2 times x plus 1 to the 4th. And finally, what we have to do is shift down by 1. So again, every point is moving down by 1. The whole graph is going to move down by 1. And this is the final graph. This is the graph of the function f of x equal negative 2 x plus 1 to the 4th minus 1.